Well, welcome to Chapter 3, Section 3.1. We're going to talk about measures of center. This should go pretty quickly since you've seen most of these before. Mean, median, node, outliers, all of these. Take a quick look. I'll pause, come right back. Here's some quantitative data. Remember, these are ones that are associated with numbers. Usually counts and measurements, like a bookcase 3 feet long, weighs 100 pounds, 3 shelves, 2 cabinets. All those are quantitative parts of a bookcase. Costs $1,500 is also quantitative, and there are numbers all over the place. Comparison. You can take a look at that. Qualitative data cannot be counted. Quantitative data, there's where you look for a number. Before we go on too much further, I'm going to slip down here and make sure my pen is active. There we go, pen. Check. Check is okay. Next. Greek letter sigma, that's the uppercase sigma, represents you're going to be adding things. And what is just to the immediate right of the sigma is what you're going to be adding. This number down here tells you where you start, and this is just a generic letter that represents what this number is going to be from one point to the other. And the points are from a 0 up to whatever that number is there. Here's a generic n, but in real cases there'll be an integer there. Next, sample mean. Very simple, something you've been using for years. These represent the actual data items. This represents how many items you've got. Add those data items up, divide by the total, and you've got the sample mean. Population mean is calculated almost exactly the same way. The only difference is that on the bottom you're talking about the number of values in the population instead of the sample. And here we are, you can take a look at those too. Notice that mu is used for the population, x bar is used for the sample. Rounding, usually use one more decimal place in what the data have. And when you're using money, just stick with 2 decimal places. Here's an example. You could calculate a sample mean. This is a sample of how many hours of sleep someone had. You want that. And notice that this is a sample. These were not all of them. The word sample gives it away. Where's my, okay, where is it? There we are. Sample. That means you are going to be talking about X bar. Pen's acting strangely. See if I can switch to this and it makes a difference. Okay, let's see. Alright, solution, add those values on the top, divide by 7, and there's your sample mean. Notice that I suggested to use your calculator for that. Put these numbers in L1, for example, and you can go to Stat, Calculate, 1 for one variable stats, and it's going to give you the mean and a whole lot more information too. To do that, there are the steps. I just mentioned those also. Next, this is what the result would look like. These are the numbers that you put in from the sample. You can see them down here. If this is highlighted. This is what you'll see at the bottom. Those are the numbers inside braces and separated by commas. That's what the result's going to look like. If you look for the sample mean, there you go. You've got your number. Here's an example. Rachel downloaded 5 new songs. She knows the average is $1.23. If 4 of the songs cost $1.29, what was the price of the 5th song? We can do that with a little bit of algebra. Here are the 4 songs we know the prices for. Here's the one we don't know. A question mark for this one. We do know there are 5 songs, and we do know the average or the mean is $1.23. A bit of algebra, and you've got the missing song's price. Weighted mean. This is one that's probably just as well done in class, but it's not that difficult. This represents the individual values. In the case of tests, those represent the individual test scores, and this represents what the weight is and how much each one is worth for each one of those. Notice that these two are a match. This might be the 7th test, this would be the weight of the 7th test, and so on. Down here at the bottom, just add up all the weights. Usually you'll see this represents 100%, although it doesn't have to. Calculating the weighted mean. This is an example. You can hit pause, go over that. Here are the scores, here are the weights. Just multiply them straight across, and add all these up at the end. And if you want to talk about grades, that would be a grade when you add all 5 of those. Got it? Okay, next. The secret of the die. I'm going to let you read that. Obviously, he is probably long gone. Calculate the weighted mean. Here's another one for you to try. Remember the tests are 40, so you match that up with the 83, match the 20 with the homework, which is with a 98, the 10% goes to the quizzes, and the final exam, 30. So you multiply the 83 times the 40, and so on. And add all those 4 products, and you got your final grade. So what's it look like? Like this. There's a test. The tests are worth 40%, and so on down the line. Do all the weights, you add those up, and there's the final grade. Walter made a good 87.9%. Hooray for Walter! To do that on the calculator, we've gone over that in class. Here are the steps in case you didn't get them or you were out. Easy to follow. If you have any questions, give me a call or give me an email and I'll get you back on track. This is what it would look like in the calculator. Notice here are the scores in one list. Here are the weights in the second list. Just go to stats and so on. And there's your result. There's Walter's score. That's his final grade. So Walter did pretty well. Alright, we can change those weights and get a quick change. In fact, if you're using TI Inspire, you can actually change those weights as you go, and it will change the results without you asking it to. Hooray for the people that TI inspire. We've got some real power. For example here, similar, if Heather has an 86.9. Here are the scores, here are the weights, here's some of the weights, and there's our final grade. You get these very easily. Good practice. See how it's done. Okay, next. Under the median, remember that's the middle one. If it's an odd number, it's just the one right in the middle. If it has an even number, take the mean of the two middle values, and you've got the median. Next, two to practice with. Hit pause, see if you can get these on the calculator or manually, whichever you like. And then come on back. So remember, with the median, you have to have the data items in order, but if you're using the calculator, you don't even need to do that, and you look for that MED if you've got a TI 83 or 84. Even on the TI Inspire, look for the MED result. There are the steps, and this is what you look for. And that's what it's going to look like, and there's our result. If we're just looking for the median, we can ignore all the rest. The median was a 6 for that one. If you do it by hand, I wouldn't recommend it, but make sure you got them in order and pick the one in the middle. Notice they're an even number, so you take those two, take the average, there's your median. There we go. Follow the steps on the TI 84 or 83, and there's your median. Done with technology instead of doing it by hand. Here are 4 more examples to try. Check to see what the mode is. Remember, the mode is the item that happens the most number of times. If there are 2 that have the same number of times, it means it would be bimodal. You'd have 2 modes. Notice that statistical packages or calculators usually don't do the mode. You have to do a bit of that by yourself. Remember, a tip is to line them up from lowest to highest, or highest to lowest, and take your eyeball down there and see which one has the most number of duplicates. Here's some for you to try. Hit pause, come on back, get the mean, which we've already talked about, the average, the one in the middle, and the mode, the one that happens the most often. Get those. Try doing a dot plot. That would be interesting. You can actually do that by doing some plotting. Hint. Stat plot. By hand. You can get those. You can use Excel. Here are the functions to use if you're using Excel. If you're using anything else, notice that the mode is always the one right in the middle. The mean is in the direction of any outliers. The median is always between the mode and the mean. So if you look at the one happening most often, or the highest on your graph, Here's your mode. The mean is furthest away, and the median is always in between them. Some tips for you. Some appropriate measures of center. Sizes, notice there are no numbers. Salaries, those will be numbers. Prices, more numbers. And some more qualitative data there. Those are your answers. Did you get it right? Inappropriate average. Please hit pause here, read through that. You might be interested, especially if you're a basketball fan. It's talking about Michael Jordan's salary and why some of the averages can be appropriate and in certain situations mean or the median are not quite the best. The mode, so the highest peak in the graphic, median, right in the middle, and the mean. Notice that it's going to be pulled toward any outliers. So if you've got a very large or very small values, the mean is not going to be very helpful. There's a picture, and the mode is usually is always the highest point. The mean is the one that's furthest away. To be toward the trailer. Look for the mean out toward the trailer. And of course, by default, if you get those two right, then this is the median. And this is the high. This is the one toward the tail, and there's only one left. And that's good to remember. Mode, median, mean, that's where they are. If you have a distribution that's just the opposite, mirror image, you still have a mode at the top. If it looks like this will be the mode. Since this is the tail, the mean is going to further out this way. Either U or X bar, and the median is always the middle one. It'll be between those two. And that's it for 3.1. See you a little bit later for 3.2. Bye-bye.